In this video, I'm going to show you one type of erosion that is found on 2 places on Earth. This type of erosion is very simple, very widespread, and scarcely talked about. The first location we see this type of erosion, this is Argentina. And the second location is in Russia. These are landscapes with parallel river valleys and very wide and very straight and streamlined river valleys. This dark green area is the low-lying land, and this is a massive streamlined feature, over 20 miles wide. These valleys are parallel with the water current. The streamlined feature has its front face facing into the current, and perpendicular to the water current are ripples. Here's another example where you can see the ripples formed parallel or perpendicular to the water current. And we also see a bunch of circular lakes and drumlins. Now let's go back to Argentina, where we notice this is also salt deposits. It also has ripples perpendicular to the direction of flow, indicated by the parallel features. Larger lakes with straight edges and lots of rutted up and beveled terrain. But let's go backwards and see how it connects to these massive canyons. Now, the green is the low-lying land. It's more lush. So the greener it is, it's more low-lying. Okay. This is the same area on the elevation map, right, where we can see the elevation change. Down here, there's also canyons as well. When we zoom in, we find a path of ruts, path of scabs and scours. Let's look at this path here. So these type of lakes tend to form in lines, and that's something we find from around the world. And then see how this is like a river's rut. And this is kind of looks like this was a trough here. And if we follow that, it might have led into this formation here. So these lakes tend to form in lines because they were scoured out under the principle of laminar flow.
One of the very first things you learn in fluid mechanics is the difference between laminar and turbulent flow. And for good reason. These two flow regimes behave in very different ways, and, as we'll see in this video, this has huge implications for fluid flow in the world around us. Here we have an example of the laminar flow regime. It's characterized by smooth, even flow. The fluid is moving horizontally in layers, and there is a minimal amount of mixing between layers. As we increase the flow velocity, we begin to see some bursts of random motion. This is the start of the transition between the laminar and turbulent regimes. If we continue increasing the velocity, we end up with fully turbulent flow. Turbulent flow is characterized by chaotic movement and contains swirling regions called eddies. The chaotic motion and eddies result in significant mixing of the fluid. If we record the velocity at a single point in steady laminar flow, we'll get data that looks like this. There are no random velocity fluctuations, and so, in general, laminar flow is fairly easy to analyze. For turbulent flow, we'll get data that looks like this. This flow is much more complicated. We can think of the velocity as being made up of a time-averaged component and a fluctuating component. The larger the fluctuating component, the more turbulent the flow. Because of its chaotic nature, analysis of turbulent flow is very complex. Since laminar and turbulent flow are so different and need...
Okay, so let's go to Russia. Here we see the drumlins are from laminar flow. That's the reason why they're shaped the way they are. So the laminar flow isn't the drumlin, it's around the drumlin, right? So this is where the laminar flow went. And over here, it went here and went around it. So the drumlins are basically in between the laminar flow. That's why they were able to be preserved. And around them, it's even undercut. And there's lakes, right? So this is undercut. Nice straight edge here. This is where the water went. And we also find large lakes and then circular lakes and triangular shaped lakes. Okay. So now let's go back to Argentina. Every time I zoom in, you can't quite see the contrast as much, but these are mounds, right? So this is a very textured terrain. But what is a spot that's really cool is this here, this perfect line of scours. So you can imagine the water current running right along this channel to make these. And that's why you get such a nice straight edge here. So that's laminar flow in a straight line. But you also get turbulence through eddies. Okay, so this eddy, you could also call that a water vortice. That's what's responsible for making potholes, which is a really amazing geologic feature. But this eddy, we're imagining an eddy or a water vortice on a 2D plane. So we would see that on the X and the Y. So an eddy is turbulence on the X and the Y. But what happens, how do we get turbulence on the Z axis, right? Like a sinusoidal wave, like we've all seen standing waves in a river. That's when there's turbulence and extra energy on the Z axis. Right here, this is like perfect. Look at that right there. That is exactly what I'm talking about. Okay. So that's the undulating force of a water current. Now, that's obviously very steep, and these are very shallow features. But in order for all of the sediment or debris or even the bedrock to be removed to make these lakes, scabland lakes, scours of all sorts, anywhere in the world, that is exactly what we're talking about. The force of an undulating water current, and it can be focused into a pit like that. So imagine all the water stopped, what would be left behind? A circular lake, right? Another circular lake here. Water bends, makes U shapes, makes a sinusoidal shape, and it focuses to make a perfect U-shaped scour. And so when we find stuff like this, where it's got a nice U-shaped scarp edge, so we can see that this was the front, and this lake here is almost 7 miles wide. So there was one undulating force that large to remove that much rock. And so when we go to a place like this, right, that's what it is here. So check this out. Laminar flow is coming straight down screen, which runs perfectly in line with this, and almost perfectly perpendicular. This would be a ripple pattern. This would be a trough from a corrugated ripple pattern, corrugated standing waves. And just like our standing wave example, focuses into a rounded shape. So that's how I think these lakes were formed. That's why they've got perfect tails, the undulating force of a water current. And they're all salty, so that even gives us info on what type of water made it. We also get, looks like, ripples across here. All these scours, all from undulating water turbulence. Turbulence on the X and Y axis, and turbulence on the Z axis, up vertical, up and down. Here we get some massive ripples, right? These are not eskers, they're ripples. Now this spot's really cool. So we've got the undulating force of water making basically a plunge pool here. And then that's in line with the cataract right here, perfectly in line. And also align with everything up for hundreds of miles, because we're talking about very laminar flow, very straight flow. Another plunge pool, river trough, cataract. Also in line, we've got all of these. So all of these are parallel river ruts, just like what we find here in Argentina. This is the river rut, this is the river rut, river rut, river rut. One here, one here. We can turn the camera and see this right here. This is double. And then, of course, all of these in between. So we're talking about a lot of high-speed water flow. And then you come over here. All right, look how pointed this is. I haven't even seen that before, actually. That's very pointed. Then you got sediment lobes indicating the same direction. So this is a teardrop shape. You actually can find a lot of cataracts in the mountains. Cirques even they call them, but they're all from water, not ice. Um, Beautiful sediment lobes here. Oh man, look at this one. Very nice. And then what's perpendicular to the flow is a ripple formation, right? Perpendicular, almost perpendicular. But we observe that in rivers all the time where it's off by about that much. That's because the river's kind of moving to the, you can see from these sediment lobes here, how they curved around. That's what's made the ripples at a little bit of an angle. You got some nice mounds, of course. And now we're getting into almost drumlins, but they're more like sediment lobes. Yeah, so you can go anywhere, zoom into anywhere on this landscape, and you will find some sort of feature. Sediment lobe, scour, drumlin. You can't, mounds. There's literally no avoiding it anywhere on this landscape. And, right, this was undulating force, almost like a ripple. Right, undulating, undulating, undulating. And then when we see it hit the ocean, this channel poured in, this channel poured in, poured in. And then when we get closer to the coast where it's really flat, we've got, still massive channels. So yeah, Argentina is kind of one of the best spots for salt scablands, massive erosion, catastrophe. This is the plunge pool. This was where it was focused the most. So that's the cool thing about water is it focuses. Even within this lake, you can still see exactly where it was focused. Just like this was focused. Same thing. All right, so let's go back to, now we're probably in Kazakhstan. Also right next to amazing drumlins, which are parallel path features from laminar flow. This was streamlined. All of this texture. Oh, this is new. It didn't used to look like this. And I probably sound pretty dumb sometimes just because I gotta do everything one take. I'll check this out. Sediment lobes. So this is actually a great spot to understand drumlins because you have to understand the negative versus the positive relief. And the laminar flow is what creates the negative relief. The positive relief being the drumlins. That's just only what's left afterwards. Right? It's only what stays. Just like mounds are the only thing that stays. And then we get drumlins of several standard deviations smaller. Pointed. Right, this would be a drumlin. Even though it's messy, it's still a drumlin. Still got the nice square lakes. And now we kind of get drumlins that look more like Australian drumlins. These also being drumlins as well. Now this location is pretty sweet. Okay, so we're right by the Turkmenistan swirl. Shout out the Turkmenistan swirl. But this location here is also got a nice curve to it. Right, so we go up here, we find drumlins. we find scours. And we can see that this has a nice curve. We can, because of understanding laminar flow is parallel flow, laminar equal parallel, from that principle, we can see a water current doing this. We can actually visualize the sweeping ocean current if you have a good imagination. And all of these troughs, you already know were dug out. Let's take a look at the bottom. I mean, this looks like a very big berm. This was undercut. It's got no sand on it. So the sand is very different from this bedrock. Okay, so we get a nice indication of a nice sweeping current here. Then we get some nice sediment lobes here. But let's go to the Turkmenistan swirl, because that's just the spot. Boom. Alright, that wraps it up for this video. Thanks for watching. Like, comment, subscribe, all that jazz.